Welcome back to The Survival Historian. Today we're resurrecting a technology so effective that it kept seafarers alive through centuries of relentless punishment. The question is urgent. Can ancient biocompounds designed for Viking warships revolutionize how we build today? In an age where synthetic sealants crack, fail, and leach toxins, what if the answer has been sleeping in history all along? The North Sea during the Viking Age was a gauntlet. Winter temperatures plummeted near freezing, and storms could swallow wooden vessels whole. Yet Vikings built ships that didn't merely survive, they conquered it. The longship remains perhaps the greatest engineering marvel of the medieval world, sleek, flexible, capable of crossing open ocean yet shallow enough to navigate inland rivers. Most crucially, watertight enough to protect warriors and cargo through months-long journeys. The secret wasn't advanced engineering. There were no synthetic polymers, no epoxy resins. Instead, Viking shipwrights possessed intimate knowledge of their environment and the ability to transform nature's materials with extraordinary precision. Clinker construction, overlapping planks, allowed ships to flex with the sea, absorbing punishment rather than resisting it. But flexibility alone wasn't enough. The Vikings solved the waterproofing challenge with materials so effective that they kept ships watertight for decades, sometimes centuries. What we're exploring is the science behind that resilience, the lost recipe for sealants that allowed wooden ships to defy time itself. Modern archaeology, combined with chemical analysis, is beginning to reveal the sophisticated understanding these ancient craftspeople possessed. The pressing question, can we recreate it? The primary ingredient was pine tar, produced through a painstaking process called tar burning. Now just imagine a Viking settlement with massive tar kilns constructed from clay and stone, burning pine wood in these controlled, low-oxygen environments. Resinous pine would be stacked carefully and gradually heated until the volatilized resins condensed and dripped into collection pits. A single kiln might only produce modest quantities, but these tar-making sites operated continuously throughout the Viking world. The demand was, well, relentless because the applications were endless. Waterproofing ropes, preserving food stores, and most critically, sealing ships. But, tar alone wasn't the complete sealant. Gaps between hull planks were first filled with fibrous material, wool, moss, or animal hair that acted as a sponge. This filler was then saturated with pine tar or tallow, rendered animal fat from cattle and sheep. The combination was, honestly, remarkably sophisticated. The fiber provided structural integrity while also preventing tar from flowing away. The tar gave waterproofing. Tallow added flexibility, preventing brittleness in cold water. As temperatures froze the tar, the fat kept it pliable enough to move with the ship's timbers as the wood swelled and contracted. The genius, really, was organic adaptability. Modern analysis of archaeological residues from sunken Viking vessels confirms this composition: pine resin compounds, animal fats and fibers, interwoven precisely as historical accounts describe. What's remarkable is that as these compounds aged, they often improved. The tar oxidized slowly, hardening into increasingly durable barriers, while the tallow's gradual degradation created microscopic air pockets that reduced water penetration. It was self-healing. The degradation of one component actually enhanced the protective qualities of another. In research laboratories across Scandinavia, scientists now subject recreated Viking sealants to rigorous modern testing. Batches of historically accurate pine tar, combined with naturally rendered animal fats and plant fibers, undergo comprehensive trials that would have absolutely astounded the Vikings themselves. Water immersion tests conducted over weeks and months show the recreated sealant demonstrates water resistance rivaling, and sometimes exceeding, conventional modern construction sealants. Temperature cycling tests rapidly shifting samples between freezing and boiling, measure resilience under extreme expansion and contraction. The ancient compound flexes and recovers, maintaining protective seals even after thousands of thermal cycles. Most compelling are UV exposure tests. Modern building sealants often degrade under prolonged sun exposure, becoming brittle within a decade or two. The recreated Viking sealant shows resistance to UV degradation, suggesting a lifespan potentially measured in centuries rather than decades. This really shouldn't surprise us. These materials evolved in open water environments exposed to direct sunlight for months at a time. They had to endure or the ships would fail, and ships that failed meant dead Vikings. The emerging picture is striking. The Vikings didn't stumble upon an effective sealant through accident. They developed materials science based on observation and iteration rather than chemical theory, but science nonetheless. They understood that flexibility mattered. They grasped that sealed seams needed to move with underlying structures. They recognized that protection required multiple layers of function. This is sophisticated systems thinking encoded in biological materials. The implications, really do extend beyond academia. Modern construction is increasingly recognizing that petroleum-based synthetic sealants contain volatile organic compounds and toxins that unfortunately leach into soil and water. These materials often fail within 20 to 30 years, requiring replacement and generating, significant waste. The built environment itself is now recognized as a health hazard, with off-gassing from synthetic sealants contributing to indoor air quality problems. A successfully scaled Viking-inspired sealant could honestly revolutionize roofing, providing the flexibility to accommodate thermal expansion and potentially extending roof lifespan by decades. Basement waterproofing, one of construction's most persistent challenges, could really benefit from a sealant that adapts with soil moisture fluctuations and foundation movement. Even window sealing and door frames could benefit from a material designed to maintain integrity under extreme conditions. The economic case becomes, quite compelling when longevity is factored in. If a bio-based alternative lasts 3 times as long as synthetic sealants, a conservative estimate based on current testing, long-term costs become dramatically favorable. The environmental accounting shifts more dramatically still. Synthetic sealants manufactured from fossil fuels, transported globally, applied once, then discarded, represent a linear model. A bio-based sealant derived from renewable pine forests lasting indefinitely and ultimately biodegradable represents a circular model. We stand at a fascinating crossroads. Historical research is clear. Vikings created highly effective sealants using simple, sustainable materials. Modern testing is promising, suggesting performance metrics competitive with contemporary synthetics. The environmental and economic cases are compelling. What remains is scaling, refinement, and bringing a medieval technology into conversation with modern building codes. This isn't simple. Fire-resistant standards, which didn't concern Vikings but are, critical for modern buildings, require testing and potential reformulation. Building inspectors and architects accustomed to synthetic sealants will require evidence and education. Production methods must be standardized and scaled from experimental batches to widespread use. These are significant challenges, but none insurmountable. The Vikings survived not through advanced technology, but through intimate knowledge of their world and patience to test and refine solutions. As we face climate change, resource scarcity, and the need to build sustainably, their example resonates with unexpected power. If this journey fascinated you, like this video to support our work. Share it with colleagues interested in how the past informs the future. Subscribe to The Survival Historian for more explorations into how humans have endured and overcome throughout history. Sometimes the most advanced solution is the one that survived the test of centuries. Until next time, keep learning, keep questioning, and remember, history is a resource, a teacher, a guide for survival.